That we need to talk about from the last chapter, tying it into where we're going, is the bonding energies. So on your AP table that you're going to get for the test, you're going to have bond energies. And it's not going to be exactly like this. It's going to be just two columns. But this is another one, so in case you come across anything combined, H and H, C and H, N and H, it has all of those bond energies. Okay, so it's not any different. The biggest thing that you're probably going to be working with are going to be the multiple bonds, and these are all in kilojoules per mole. That's obviously what we work with. On the test that you just took, if you use my advice, and I'll say it so everybody can hear it, about looking at what unit was wanted, solve the answer in kilojoules per mole, and you had grams, you convert the grams to mole and divide by the kilojoules you had. That's all you have to do for all the AP problems, is know what unit it's asking, and then from there, I mean, I think I gave Spencer a little tip on the way, and I think it helped you, right? You just have to look at the units. If you know the units, you're going to be successful. All right, so we have this. So this is what we're going to do. We're going to move up and down a little bit here. All right, so we're going to write a balanced equation of the combustion of 1 mole of ethane, C2H6, forming H2O. So go ahead and do that now. You should be able to do that, no problem. Make sure you use the shortcut that I gave you last week. So use that shortcut. All right, so you should be done. Should be very easy. So I have C2H6 and then O2. All right, so now what is the shortcut? Somebody explain to me the shortcut that I'm going to do. What would I have to do? Yes.
Well, after you did C and the H balancing, when you have how many oxygen you have on the right side, you just take that number and put it over 2 as the number you put.
All right, so what should I put? What should I put right here first? 2. All right, what should I put right here? 3. All right, so now what I'm going to do, so you know it if you're not here, see how many oxygens I have. I have 4 there, 2 times 2, and I have 3 here. How many is that total?
7.
All right, so I put 7 halves. And why am I doing it that way? Why do I do it that way? Yes.
So you have 1 mole of
All right. It's asking you for 1 mole of ethane. So if you change that coefficient there, then you're not going to be able to get the right answer. You have to divide by 2 or 3, whatever that coefficient is, when you calculate it out. Okay, so the next thing we're going to do, just to start getting into it, some of you have already been exposed to this. This isn't hard. We're going to draw structural formulas, Lewis structures for each of the molecules involved. Somebody tell me when it's 10:45 so I can stop the recording and not have a monster recording. All right. Looking at the periodic table or periodic table that you have in front of you, how many bonds can a carbon make? 4 bonds. All right. How many bonds can a hydrogen make? How many? 1 bond. All right. So then what has to be in the middle? My carbon. They're going to be combined with each other. How many bonds does each carbon have left to use? 3. All right, so we're just going to go like this. This is going to be very easy, a basic introduction. And off that, I'm going to put my hydrogens. And how many hydrogens do I have? 6. All right, so that was an easy one. That's good, right? You remember this. This is good. We get a lot of orgo in SL. Okay. Now we have to do O2. So we look at O, and we got another O. We have to figure out what it's going to have. What is it going to have? How many bonds can O form? It can form 2. All right. So if I have O2, it's going to form a nice double bond for me here. I'm going to be left with how many valence electrons? How many electrons am I going to be left with? Let's review. So All right, let's review this real quick. I'm going to go ahead and change colors to a black. Each line represents how many electrons? All right, so 2 electrons. So this is 2 here. This is 2. How many do I have here? 2 and 2. So each one can have how many? What is it? 8. Make an octet. So each one can have a total of 8. So what are we going to do with the 2 in the middle? What's happening with these 4 right here? What are we doing? They're sharing. So if you made a Venn diagram, this would be very easy. So I'm going to go ahead and plug, I'm going to do another box here for this oxygen. And how many electrons do I have on this side? Well, I got 2 again, 2 again, 2 here, 2 here. How many does it have? 8. So the biggest thing to remember, you can start with what you had. Oxygen has 6 valence. That means it needs 2 more. And how do you know how many valence it has? Valence electrons equals group number. Absolutely. All right, so if you didn't know that, valence electrons equals group number. All right, so now we have to do carbon dioxide. Now, each oxygen has how many bonds? Can it take how many bonds? 2. Carbon can take 4. This should be pretty easy. What do you think we're going to do? Carbon? What do you think? Double bond to an oxygen. Double bond to an oxygen. Don't forget, I need my valence electrons at the end. How many are oxygen going to have left? 4. All right, so 1, 2, 3, 4. All right, so I shouldn't need to go over that. I just went over how you get 8 total on that one. This electron's a little bit small here. It's probably about 8 gazillion electrons in that one. All right, and then H2O, Spencer Magladree. All right, so let's draw it so we actually are starting to see its shape, right? So it's going to be a little bit different. We're going to put those pairs up top. They're going to bend away those bonds, and we're going to get kind of see that shape of water forming. Okay, now we need to calculate the bond energies of the reactants. Again, tying into what we did last unit with what we're doing this unit, so we see the whole picture. Okay, so how many CH bonds do I have? How many? 6. So go back up to the top and tell me what CH is going to be. What is it? 413. So this is from the top, from top of page, for those of you not here. All right, so 6 times 413 gives us what? Okay, very good. All right, next, let's do, how many CC bonds do I have? How many? I have 1 CC bond. Here it is. 1 CC bond. And what is that? 346. I have 1. 1 times 346 is 346. All right, how many O double bond O bonds do I have? All right, so make sure you go up top and circle the ones we're using. So before you've done anything else, circle the ones up top on the chart that we're using, just so I can come around and check. Did you not pick up the papers? No. Yeah. I'm just making this up from my head. Good. All right, good, 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 good. All right, so what do I have for O double bond O? 498. Now, I can't fit this in the box. I'm just going to put 7 halves right here. So somebody tell me what we get when we have 7 halves of 498. What do we get? Anybody? Bueller? Bueller?
1743.
Perfect. Okay, so now what we need to do is do the total bond energy of the reactants. What do you think you would do with all these lovely numbers? Add them up. So I'm going to add them, and I'm going to put that answer right there. So let's go ahead and do that. Somebody give me an answer. I'm going to go ahead and make it in a lovely Halloween color because it is tomorrow.
4, 5,
It's
6,
candy. What'd you get?
4, 5, 6, 7.
Stop it. I'm going to go ahead and put my units there just because I'm a freak like that. Some people lost some points because they didn't have units on their answers. Okay. Now, we need to calculate the bond energy of the products. All right, so how many handy dandy C double bond O's do I have? 4. How did you get 4?
You have 2 and 1 molecule of CO2 and 2.
Okay, so look at, let me just reiterate this. If you look up here, all right, and then you bring that down here, this 2, let me change colors. This 2 right here is going to double the amount that you have here. All right, so good. All right, so I'm going to say 4. And what's my original C double bond O? Circle it up top. Somebody tell me. What? 799. Check it out, 799. And I have 4 times 799. 4 times 800 is 3200. Minus 4 gives you 3196. You know what I just did right there, right? Math T? All right, OH, 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 OH. Now, I'm going to go ahead and use a fancy-dancy color that isn't matching anything else up there. Now, how many OHs do I have? How many? Well, right here, I have how many? I have 2, but I have 3 here. So 3 times 2 is going to be 6. And what's OH bond? What's the energy on that? 463. How many kilojoules per mole am I going to do with 463? 6 times 463 is going to be?
27.
70. All right, perfect. Total bond energy of the products is 5,974 kilojoules per mole. You pick this ball up and you run every one of them. All right, don't fumble my football. Don't fumble my football again, Melissa. Don't fumble my football. All right, so we got a little bit of work there. We got some good colors. So remember those numbers. I'm going to move down to number 4. Anybody need more time on this? Okay. All right, so sliding down, finish up page 1. Let's just do that together. So the delta H of the reaction is the bond energy of the reactants minus the bond energy of the products. What is the delta H at combustion of the bond energies? What would I do? So let's see. Delta H of the reactants. Minus delta. That's I don't like that. Sorry, 1 second. Sorry. I know it's right there. I know. RXN reaction. Okay, so what's the bond energy of the reactants? What is that? What number do we have? 4,567 kilojoules per mole minus 5,974 kilojoules per mole. And my answer is in Halloween orange, what? Negative 1,407 kilojoules per mole. Is that hard? Well, you get those right on the AP exam because those questions are given to you quite often. All right, So does this negative sign make sense? Does it make sense? Yes, if you're combusting something, it's burning. Combustion equals burning, which means heat. Heat. Give it off. It's getting hotter. So just so you can kind of tie it all in. All right, tie it all together. All right. So what I want you to do real quick is try number 5. Number 5. All right. Try number 5. Should be pretty easy.